Hey you guys, we're in chapter 5, section 5, and we're kind of at the bottom now as far as our objectives go. In this video, we are going to use conjugates to write a polynomial given the roots. Alright, so writing a polynomial function using the conjugate root theorem and given roots. Our step 1 is to plug our roots, or our zeros, into the factors. Then, step 2, we will double distribute. Alright, so in this example, it says our root is 3i. Well, according to the conjugate root theorem, if we have 3i as a root, we also have negative 3i as a root. So I'm going to take my roots and plug them into their factors. So I have x minus 3i, and I have x plus 3i. Notice I'm taking the opposites. So this was a positive, but I said minus. This was a minus, but I said positive. Because if I were to solve each of these, then I would get the root shown. Now step 2 says just double distribute. Well, I'm not going to actually double distribute since these are conjugates. Instead of double distributing, I'm just going to say first times first and last times last, because my middle terms are going to end up canceling out. So for f, I say x times x, and I get x squared. For last, I'm going to say negative 3i times a positive 3i, and I get a negative 9i squared. And then you have to remember that I squared, when you see it, you really are going to cancel it out and change the sign. So the polynomial is really x squared plus 9. And this is our answer. So x squared plus 9, if we were to go and solve to find our roots would be 3i and negative 3i. Alright, let's take it to another level. For number 2, we're given these two roots, 3i and negative I. Well, again, according to the conjugate root theorem, if 3i is a root, then I know negative 3i is a root. And if negative I is a root, then I know that positive I is a root. So now I'm going to write my factors. So for 3i, I have x minus 3i. For negative 3i, I have x plus 3i. For negative I have x plus I. And for positive I have x minus I as factors. Again, I have the opposites of what it appears to be. Now I'm just going to take 2 at a time and multiply them together. I'm going to multiply my conjugates together because, again, instead of having to do FOIL or double distribute, you just have to do Florida. So the f here, we get x squared. And the L, when I multiply that, I get negative 9i squared. And keep these in parentheses. Alright. We saw previously, though, that I squared, we really cross it out and change the sign. So I'm going to rewrite this as x squared plus 9. Alright, and then we're going to do the same thing with our other two. These are conjugates. So instead of foiling, I'm just going to say first times first and last times last. So for my f, I get x squared. And for my L, I get I times negative I. So I get negative I squared. And again, when you see an I squared, you cross it out and you change the sign. So it's going to be plus 1. And I'm going to rewrite that down here. So I have x squared plus 1. Now, these are not conjugates. So I'm going to have to FOIL all the way, or double distribute. So x squared times x squared, I get x to the 4th. X squared times 1, I get positive x squared. 9 times x squared, I get positive 9x squared. And 9 times 1, I get 9. And simplifying that, my polynomial will be x to the 4th plus 10x squared plus 9. And these are my answers. Or rather, this is my polynomial that when you solve for the roots, These are your roots. All right, looking at number 3. Number 3, we are given the root of the square root of 2, so we also know that an additional root would be negative square roots of 2. So we're going to write those in their factors, x minus radical 2, and then x plus radical 2. Again, since they're conjugates, I only have to do Florida instead of FOIL. So first times first, for my f, I'll get x squared, and last times last, negative square roots of 2 times the square root of 2 is negative square roots of 4, or just 2. So x squared minus 2 is my polynomial that when I go and solve for the roots, I would end up with these guys. All right, you guys, you have a couple to try. Here you go. You try these two, number 4 and number 5. Careful though. Remember, it's the conjugate root theorem that gives you the opposites. So for number 4, only take the opposite or the conjugate of irrational or imaginary numbers. And use that same hint for number 5. All right, see you guys in class. Thanks.